Allow me to take you through this lesson, and this lesson I'm going to introduce now is about lenses. I know in senior 3, senior 2, senior 3 or 4, senior 3 there, you must have covered or you must have come across what they call lenses. Lenses, diffraction through what? Through lenses. So we shall say that there are two types of lenses. There are two types of lenses. One, convex stroke converging lenses. So we have this type of this one we shall call it biconvex. Biconvex because it has two surfaces which are curved. Then we have another one. We have that type, and we shall call it plano convex. Then we have another one, it's like this, like that. We shall call this one converging meniscus. Meniscus. Then we have number 2. We have concave, or another one is we can use diverging what? Diverging lens. So we shall have this one. We shall have this one. Two surfaces are curved. This one we shall call it biconcave. Biconcave. Okay? That is by what? Concave. Then we have another one. Okay? We have this one. One side is flat. Then the other one is curved. This one is plano concave. Plano concave. Then we also have the diverging meniscus. Diverging meniscus, which is like this. This is diverging meniscus. Diverging what? Meniscus. Then we go to terms used. Terms used. We shall have a diagram. This is F2 F. This is F2 F. Let us put an object here. This is image I. So terms use it. That's C. Terms use it. 1. Principal axis. So we have principal axis. Principal what? Axis. We shall now say that it is the line passing through the focal, the principal focus and the centers of the lens. That's number 1. Number 2, centers of curvature of lens. Centers of curvature of lens. We say these are centers of spheres for which the lens surfaces form parts. Form parts. Then number 3, radii of curvature. These are distances. Radii of curvatures. These are distances from the centers of curvature to the centers of spheres for which the lens surfaces form part. Form part. Principal. Then the other one is optical center. Optical center C is the midpoint of the lens. The midpoint of the lens surface through which lays incident on the lens are undeviated or pass through undeviated. Then number 6, paraxial rays. These are rays cross the principal axis and make small angle with the principal axis. Then aperture we shall say that this is the width, okay, or the length of the lens. Then we shall also say the other one is a focal plane. Focal plane. Okay, you say this is the plane containing the rays passing through the principal focus and is perpendicular to the principal axis. Then we go to ray diagrams. Ray diagrams. Ray diagrams. Now, in these ray diagrams, when you are drawing ray diagrams, there are 3 rays that you choose 2 of the 3. The first one is this, that the ray parallel to the principal axis after refraction passes through F. Number 1, a ray parallel to the principal axis. A ray parallel to the principal axis after diffraction passes through F. Or for diverging rays is this. After refraction, it will appear to be coming from F. That's 1. Number 2, we say a ray passing through the center of the lens, or the ray passing through the optical center passes through undeviated. Undeviated means that it does not bend. I.e., like that. And what? Deviated. Next, number 3, a ray passing through principal focus. Number 3, a ray passing through principal focus after refraction. After what? After refraction, it goes, or we can say it is refracted parallel to the principal axis. It is refracted parallel to the principal axis. So, when we are drawing ray diagrams, we shall use 2 of those 3 rays. We don't use both. If one can use both, but it is wasting what? Time. Because an image is formed when 2 rays intersect. So why do you use all the 3 rays? Yet we need 2. So now let us start with it. We start with convex what? Convex lens. Convex lens, we shall start with object pressed between F and C. Object pressed between F and C. See that? Object pressed between F and what? And C. So this is how the diagram will look like. I hope it is clear. I think it here. This is how the object pressed at C. Now this one, this arrangement we shall call it magnifying glass. And as you can see, the image formed is virtual, upright, or erect. It is magnified. That's why we call it magnifying glass. So that is the object placed between F and optical center of the lens. It forms that kind of image. That's the ray diagram number 1. Number 2. The object pressed beyond to F. Object pressed beyond to what? To F. I think you can see the image is diminished, inverted, and it is real because it is formed by rays which are actually meeting, and it is formed between F and 2F. Is that okay? Then another one. We shall have image, the object pressed at F. Object pressed at what? At F. Object pressed at F. Is that clear? Object pressed at what? At F. So the image is formed at infinity. So those rays, those two refracted rays should be parallel to each other because the image is formed at infinity, and besides that, the image formed is real. Yeah. Next. That is the object pressed at what? Next, the object between F and 2F. I see it. The object pressed between F and 2F. Okay? The object pressed between F and 2F, you can see it is magnified, it is real, it is inverted, formed beyond 2F. Yes. Then we also have another one. The object pressed between F and 2F. Between F and 2F. Here. Hey, have I showed you this one? I think I've shown you this one. Between F, 2F and F. Magnified, real, and inverted. Then we have another one. Object formed at the object pressed at 2F. It is here. Object pressed at 2F. Like in mirrors, in concave mirrors, when the object is pressed at the center of curvature, it forms the image at the center of curvature of the same size. So the same thing with this. The image formed is of the same size. It is formed at 2F. It is real and inverted, and the same size, the same height. Okay. That's number 1. Then number 2, diverging lens. Diverging what? Lens or a concave lens. So a concave lens is like this. Okay? That is how the image is formed. The image which is formed is virtual, upright. It is formed between C and F. Okay, and it is diminished. And it is what? Diminished. So that's the ray diagram. Okay? Yeah. We move on. Next, we shall say uses of concave lenses. Uses of concave lenses, I can also talk about them. They are used in spectacles for short-sighted people. They are used in Galilean telescopes. Uses of convex lenses. They are used in spectacles for long-sighted people. They are used in optical instruments. They are used as solar concentrators. And they are used as magnifying glasses. Magnifying glasses. Yeah. So can we move on? Then we move on, we say thin lens formula. Thin lens formula. Thin lens formula. So we shall start with a point. We have two cases. Okay, number one, we shall start with convex lens. Case one, point object. Then we shall have consider a parallel beam of light. So we shall have this diagram. Then we consider a parallel beam of what? This one, parallel beam of. Now, but we said that a ray which is parallel to the principal axis, after diffraction, it passes through F. So we shall have our F on this side. This is our F. Such that the distance from here is focal length. And then this angle of deviation is here, which is same as this angle, and this is H. Then we shall say, for small angles, in radianis, tan of D approximately equal to D, which is equal to H over F. Equation 1. Then consider a point object at a distance what? From the lens. So we have this. This is the lens. Then you have this axis. We have point object O at the distance U. Then we will complete. We shall have this. It's forming an image at the distance what? At distance V. Forming an image I, which distance? Distance V up to here. Okay? So we shall now say let this angle be alpha, let this angle be what? Beta. This is still the same angle of deviation, and this is H. Okay? Then we shall say that the sum of two inter angles add up to one exterior angle. That's equation 1. For small angles in radianis, tan of alpha approximately equal to alpha, which is H over U. Tan of beta approximately to beta, which is H over V. So this is equation 3. So we can say put 1 and 3, putting 1 and 3 into what? Into 2. So we shall say alpha is H over U plus H over V should give us H over F, which now gives us 1 over U plus 1 over V equals 1 over F. Very important equation. Then we go to case 2. Case what? Case 2. Using finite what? Object. Using finite what? Object. So we have this. Have this one here as principal axis. Let me say an object is here. This is the objective. Then here we shall have like that. Then here we shall have this. Let me say up to here, and the final image is formed here. So this is object. This is F. Let me say F is also here. So this is I. Let us call this is B. We call this one X. This is OA, like that. So here we shall also do this. What we are going to do, we are going to extract the triangles which are similar. For example, if I move along what? Along AB. This is C. This is O. This is I. Okay? So I will say that this one OA divided by what? Divided by IB. The distance is OC divided by what? By the distance which is IYT. So this is OC. OC is U. You create it there. This is U. Then this is what? This is V. Then this is what? This is F. Which is OC is U divided by IC, which is V. And call this one divided by 1. Where C is this one? We go to the next one. The next one says, we go to X. This is X, this is B. Passing through F, this is F, this is C, yeah, this is I. So we shall say that X divided by IB should give us, this is FC divided by IF, which will now become FC, IF. How do we get IF? IF, we can say it is IC minus FC, which gives us, this is F over V minus F, Then, but OA is same as X what? XC. So 1 is equal to 2. Equate U over V will become what? Will become F over V minus open brackets. We shall have VF equals UV minus UF. That means that VF plus what? UF is equal to what? Is equal to UV. So dividing through UV what? F. Dividing through UV what? F. Here we shall have over UVF over UVF over UV what? F. So it means that we are going to say that this one is same as, it is same as 1 over F here, 1 over F equals 1 over V, 1 over V here, 1 over U plus 1 over what? 1 over V. As simple as that. Then we shall move on to diverging or concave what? Concave lens. Case 1. Point what? Object. So we shall draw the diagram. Point object, draw the diagram. Consider a pair of beam of what? A pair of beam of light, okay? So let's consider a pair of beam of light. Consider a pair of beam of what? Light, like this. It will be diverged. So it diverges, it goes up, like this. Okay? But this arm here is, this is arm of deviation. Then this is F. This will also be arm of what? Deviation. And this will become negative F. Okay? This is H. Then we shall say that for small angles what? For small angles in radians, we shall say tan of D approximately equal to D, which is H over negative what? F equal to 1. Then Consider a point object which is placed at a distance u from the lens. So, come here. This is the lens. Then let's consider this O at a distance which is what? Which is u. Okay? So we shall have this. It's going to diverge. It's going to diverge here. Like that. Then this is image is I at a distance which is what? Which is negative V. This arm here is D. Which arm here is also D. Then we shall say this is alpha. This is beta. This is H. So we shall now say that the sum of two interangles, alpha plus D, should give us beta. So alpha minus beta, D will become beta minus alpha. That's equation what? Equation 2. Then you go ahead. For small angles, what? In radians. For small angles in radians. Tan of beta equal to beta, which is H out of negative V. Tan of alpha, which is H out of U. That's equation what? 3. From put 3 and what? And 1 in 2. In what? In 2. So we shall have. We are going to have, when we put, then that means this is D, that is H over negative F is equal to beta. Beta is H over negative V minus H over U. So this will be 1 over F equals 1 over V plus 1 over U. Very important what? Equation. Then case 2, that's the finite what? Object. Case 2 is the finite what? Object. So we do the diagram. I have this. Sorry. I have this. Then this is object. This is O. This is L. And come now when it is refracted, it will appear to be coming from where? From here. So we shall have this. Like that. Then what next? This one will come like this. Like that. Like this. Where the image is formed here. The image is formed here. So this is I. The distance is negative V. This is C. Then what else? This is X. Okay, like that. So in this case, we're going to say what I'm going to say there. In this case, we shall now say that we start with AC. Starting with AC. AC. We have this. We have this. We have this. This is O. Then we have also the small one, which is this is I. This is B. Call it B here. So I shall say that OA divided by I what? ID will give us OI divided by IC. But OI is same as OC minus IC. IC divided by I what? C. Which will become OC is U. OC is U. U minus IC is negative V, which becomes plus divided by negative V. So which gives us U plus V over negative V. Okay? Then this is equation what? 1. Then also consider XF. Consider X what? X, this is F. So it's like this. This is C. Then this is F. This is I. Okay, this is B. So that we say that XC over IB will give us FC over this one is IF, which is FC. Now IF is FC minus FC minus IC, which gives us F, negative F over this negative F minus V. Okay? Which gives us negative F over V minus F. Equation 1. So equation 1 is equal to equation 1. Like that. So 1 is equal to 2. Okay, so we substitute. We shall now say equation 1 is U plus V over negative V is equal to negative F over V minus 1. Have cross multiply. This is UV minus UF. Then plus this square. I think there was a mistake somewhere. To get this one, we shall say here we have XC divided by IB, okay, which is same as the distance is FC divided by IF divided by I what? F. But then to get IF, we shall say it is F will be, so it will be IF will be FC minus IC, which is FC, which is negative F minus V, which is negative F over V minus F. Now equation 1, let's go back to equation 1. To get, this is equation 1, this is ON divided by IB, okay, is equal to, this is OC, there is a mistake here, this is OC, the whole length, okay? OC. So OC divided by IC, which is OC here, divided by IC, and the answer here will come OC is same as what? OC is our U. So we made the mistake here. It's supposed to be U like that. So cross multiply, we shall say it is UV minus UF is equal to negative, is equal to plus VF. Okay? So meaning that UV will become VF plus U divided both sides by UVF, UVF. So we shall have 1 over F equals 1 over here will go, V will go, F will go, 1 over U plus 1 over V. Very important equation. Plus 1 over V. Very important what? Equation. Then we move on. So that is the case what? 2. So we are done with the Lenz's formula. Then let us go and look at alternatively. You can also use the magnifying glass. Use magnifying glass, you'll be able to come up with that equation. Magnifying glass for a convex lens. When you use magnifying glass for a convex lens, you'll come up with the same formula. That magnifying glass is when there is a virtual image, and a convex lens forms a virtual image when the object is placed between F and C. So when you place the object between F and C, you get a virtual image which is upright and magnified. So using that one, you can also come up with the lens formula. Yeah. Then power of the lens. When we talk of power of the lens, power of a lens, this one is the reciprocal of focal length in meters. Its SI units, diopters, which is a capital D. So power is equal to 1 over F4, but this one must be in meters. For two lenses in contact, combine the power, Q will become 1 over F1 plus 1 over F2. Then F is negative for concave lens and positive for convex lens. So take note of those things. Then we are also going to look at what they call linear magnification. How do you get linear magnification? We shall say by definition that linear magnification is the ratio of image size or height to the object size or height. Yeah. Then from there we can also look at the least distance. The least distance between object and I think between an image, between object and real image, or an eye. So let us check that distance, how to get it. This is the lens. Then let's say an object is here. This is the real image for you. Want from the real image. This is I, and this is the objective O. So we can now say that let this one be formed at the distance what? Distance x, and then here the distance is d. The distance is what? Is d. So this becomes d minus what? D minus x. D minus x. Then we shall now say 1 over f equals 1 over u plus 1 over v. 1 over f is equal to 1 over x, d minus x, 1 over d minus x, then plus 1 over x. LCM is x into d minus x This is x plus d minus x as 1 over f. So x will cancel, 1 over f will now become, this is d over x into d minus x. So we shall say that our f d will now become xd minus x what squared. So that means that x squared, okay, minus xd plus fd is equal to 0. Then, when we reach there, we shall now get Fourier image to occur. Of course, we can first get it, say, x using the equation is minus b plus or minus. So, this is minus negative, this one which is d plus or minus square root of 4ac. Okay? B squared minus 4ac. So, this is d squared minus 4 times a, that's fd, 4ac is this one, divided by 2a, which is 2. Then we shall now say Fourier image, Fourier roots. Fourier what? Fourier roots. Those are in mathematics, you know. Fourier image, Fourier roots, Fourier image, it means that d squared minus 4d squared minus 4fd should be greater or equal to what? To 0. So that means that, what does it mean? It means that our d squared, okay, our d minus 4f should be greater or equal to 0. That d should be greater or equal to 4 what? F. That means d should be equal to 4 what? 4f. So what does it mean? It means that if the image is to be formed here on the screen, then the distance between the screen and the object should be 4 times the focal length of the lens used. If the lens is of focal length 10, the focal length what? 10. That means that the distance between this and this, it should be 4 times 10, that's 40. Should you press them at the distance below 40, then you will not get a real image. Is that okay? You will not get a real image. Yeah. So then, okay. So that means that there is the distance between the object. There is distance between the object and your image. The object and your image. Okay? Formed by convex lens is forward for greater or equal to. So these questions are very common, of course, in the question banks. Those questions are there. You will get there and then be able to get it. The solution is for those. You know, when you get this knowledge, it will help you to handle very many questions in the question bank. There are very many questions in the question banks that were set by NEP some years back. So please go there, revisit those question banks, but do not use the solution banks. Use question banks. Then revisit them and then do those numbers. You read, after reading, then attempt the numbers. Then take it to your teachers for marking. Okay? Yeah.